Scientific Measurement, Chapter 3. Measurements and their uncertainty. We're going to talk about those. First of all, if we're talking about a measurement, we're simply talking about a quantity that has both a number and a unit. So we're talking about something like 5 miles. Quantity 5, unit miles. 5 miles would be a quantity, number, and a unit. Or 3 feet. Those would be examples of measurements that we're talking about. And when we're talking about stuff in science, measurements are fundamental. You have to be able to measure things. And it's important as you measure things that you do this correctly. And so we're going to talk about how, what we're going to worry about and things like that. Most of you are probably familiar with scientific notation. You know that we're talking about a coefficient, times 10 to some power. So for instance, we're looking at something where we would have maybe 2.5 times 10 to the 14th would be an example. So here's my coefficient out front times 10. This is what we have, makes it exponent raised to the 14th power, or something like 1.2 times 10 to the negative 3. Now, understand or remember that when we're talking about this, we're talking about a positive exponent, we're going to move our decimal place to the right. So I would move it over 14 places. It'd be a 2-5 followed by 13 zeros. If I'm talking about a negative exponent, I'm going to move my decimal place to the left. So I'm talking about 0.0012 would be what we're looking at right here. Okay, so that's exponents. I think most of you have done enough with those that you should be pretty familiar with it. Also, it's important that you know how to do exponents on your calculator. And different calculators are different, so it's important that you read your instruction manual as to how to put it in for your calculator. A lot of people just kind of assume that accuracy and precision are exactly the same thing, but they're not. In science, they are two totally different things. We're talking about accuracy. We're talking about how close the measurement is to the true value, to what it really is. So if we're measuring something and trying to, we knew it was exactly supposed to be 4.5 inches, and we got 4.4. Our accuracy is off by a tenth. So that's what they're talking about. Accuracy is how close you come to the actual measurement. Precision, on the other hand, is how duplicatable something is. So it's how close you come over and over. That's what we're talking about when we're talking about precision. So let's actually, before we go on, let's take a look at kind of a difference here. So if I want to talk about accuracy, accuracy is how close, this is my bullseye. Accuracy is how close did I come to the middle. If I shot a dart or threw a dart or shot an arrow or something, how close did it come to the middle? Precision is how close together your measurements are. So those are more precise. They're not accurate, but they're more precise than if I have something like that. That is not very precise and not very accurate. So to get accurate, you've got to be in here. To get precise, you need to be close together. That's the difference between those two things. So to evaluate accuracy, we're going to take the measured value and we're going to compare it to the correct value. But we've got to know that. To evaluate precision, we want to be able to repeat what we did. Okay, and we'll do the accuracy, precision stuff in class tomorrow. We should do that. All right, let's talk about error. If I want to figure out my error, because anytime that I measure something, I'm going to have error. That's just what's going to happen. So the first thing you need to know is what the accepted value is. Accepted value would be based on reliable resources. Typically, if we're talking about like the accepted value for the boiling point of water, it's 100 degrees because they've done it enough that that's what it should come out to be. So there's usually some kind of table or some kind of set value for those particular things. Then you have the experimental value, which is what you measure in the lab. So you go in the lab, you'll do that yourself. This is what you will always do, is the experimental value. The difference between those two is your error. So if I measure something and I get 4.4, but we know the answer was supposed to be 4.5, my error is 1/10. And so we're just going to subtract those two. That's going to be my error, accepted value minus or experimental value minus the accepted value. But normally, that doesn't really tell me something. If I tell you that I'm off by 1/10, is that good? Is it bad? It depends. If I'm off by 1/10 when I'm measuring something that's miles, 1/10 of an inch, let's say, when I'm measuring something that's miles long, that's not very much. But if I'm off by 1/10 of an inch when I'm measuring something that's only a half an inch long, then that makes it a whole lot different. So what's better is when we talk about percent error. And percent error is the absolute value of the error divided by the accepted value. So for instance, here's what we're talking about. Remember we said the error, if I spell it right, error was equal to the experimental value minus the accepted value. If we want to find the percent error, it's the experimental value minus the accepted value, and we take the absolute value of that. In other words, we don't want any negative percents. And we divide by the accepted value. And I don't have enough room, but I should take this times 100 to get a percent. So times 100. So let's rewrite it. So percent error is going to equal the absolute value of the experimental value that you found minus the accepted value that you find from reference divided by the accepted value. Value times 100. That's how I figure out the percent error. All right, that should do it for this section.